So we will start with the tasks and functions in SystemVerilog. So these are very important concepts in SystemVerilog. So before going to the tasks and functions of SystemVerilog, first we will brush up our concepts of Verilog. So basically, task and function in case of Verilog will brush up our concept of task and function in Verilog. So basically, task can have delays, wait statements in case of Verilog, and functions should not have any wait statements, delays, and any type of delays in case of functions. So a task can have input as well as outputs, whereas a function in Verilog should have only inputs, no outputs, and inouts are allowed in case of functions in case of Verilog. And a function should always return some value. So a function should always return some value in case of Verilog. That is, functions cannot be void. Cannot be void. Meaning of void is nothing is written by the function. So functions in Verilog cannot be void. And in functions or tasks in case of Verilog, we should use begin statements in functions and tasks. So we should use begin statements in case of functions and tasks. So these are some of the concepts in functions and tasks. And in case of tasks also, so if we declare any task, so we may declare arguments or we may not declare any arguments. Here arguments are optional. Whereas in case of functions, input argument must be specified because they are not void. Input is mandatory. We cannot mention output and inout, and input argument is also mandatory, and these functions are not void. The functions cannot be void type in case of Verilog. So these are some concepts in tasks and functions in Verilog. Now, what are the enhancements which I have done in SystemVerilog? So in case of SystemVerilog, the first enhancement is functions can be void. Functions can be void type. That is, these functions cannot return any value. So these functions may not return any value. For example, function void, say if we are displaying anything, we can use this display. The name of the function is display, and we can use $display. We can display something. So basically we use void functions for displaying something, and end function. So these functions are used to so these functions can be void type in case of SystemVerilog. So these void functions will not return any value, whereas normal functions, if we not declare any void function, for example function sum, input a comma b comma c, and output sum. So the next enhancement in SystemVerilog is functions can have input arguments as well as output arguments. So this is another enhancement in SystemVerilog. Here functions can have output arguments also as well as input arguments, whereas in Verilog we cannot have output arguments, we can only have input arguments, whereas in SystemVerilog we can have output arguments also. and this function is not a void function, so it will return the value in the to this variable sum. Since this sum is output, so we will get the value of sum, so the output of this function is sum. So this function is returning some value with the help of output. And similarly to Verilog, we cannot have delays, wait statements in functions of SystemVerilog. So in SystemVerilog also, we cannot use delays, wait statements in functions. And this function should be executed in 0 time. This function should be executed in 0 time units. In case of both Verilog as well as SystemVerilog. So the first enhancement is functions can be of void type, whereas in case of Verilog, functions cannot be void type. And the second enhancement is functions can have input as well as output. And the third enhancement is both in functions and both in functions and tasks, both in functions as well as tasks in SystemVerilog, the functions or tasks may not include this beginning statements. We can use these beginning statements, or else we can leave this beginning statements, no problem. There will not be an error. So beginning statements is optional in case of functions and tasks in SystemVerilog. So these beginning statements are optional in functions and tasks in SystemVerilog, whereas in case of Verilog, we should use beginning statements inside this functions and tasks. And we have some concepts called return, and we can pass the values to this functions or task by two methods. One is called pass by name and pass by reference. And in case of functions or tasks, if we are writing any argument, say suppose a, b, c, here also in case of m, n, o. So if we are not mentioning the direction of the argument, then by default it will be taken as input. So if we are not mentioning any arguments in if we are not mentioning the direction of the argument in functions and tasks, then it will by default take them as input. So these are the some basic introduction to functions and tasks in SystemVerilog and the difference between the functions and tasks in SystemVerilog. So is this clear for everyone? Is it okay? Okay. Now coming to this usage of functions. So why we are using these functions? So these functions are used in the cases where we want to compute something. For example, sum is equal to a plus b. So if we want to use this statement many times in our block or in our module, so if we want to use this statement many times in our module, so instead of writing this sum is equal to a plus b every time, we can call this function. So this function will calculate this value and it will return this. So instead of performing this step every time, we can call a function wherever we need this value. So if we want the value within no time, within 0 time units, then we will use a function. Or else if we want, or else if we can use some delays, or we can include some delay in that calculation, then we can use the task. So this is where we can use function and tasks in our coding. So these are the usage of functions and tasks in SystemVerilog. So these are the basic concepts of functions and tasks in SystemVerilog. Please wait a minute. Functions in SystemVerilog. So we have already discussed this. Functions cannot have any delays in it, and it cannot have any wait statements. And a function cannot start a task So this is one of the important point. So functions cannot call tasks. A function can call only other function. So a function can call only other function, but a function cannot call a task. Whereas a task can call a task. So a task can call a task, whereas a task can call a function also. But vice versa here is not possible. Function cannot call a task. Why? Because functions should be executed in zero time units, whereas tasks can have a delay statements. So functions cannot call a task because it cannot wait for the task to get uh, completed. So that's why we cannot call a task with the help of function. But if a task is getting completed in zero time units, we can call a task. But if the task contains any delays, then we cannot call a task with help of function. And a task can call a task as well as task can call a function. So these are some important points. And let's take an example. We will discuss about void functions. We'll start discussing about void functions in SystemVerilog. So let me write a module. So I'm writing a module TB, and here I will declare two integers, say int m is equal to 10 and n is equal to 20. And I'm writing a function called display. So for displaying, we can use this void functions, function void display, and there are no arguments in this void function since this is not returning any value. So since it is not returning any value, it is a void function and no need to write any input or output arguments. Just I am using it for displaying some statements. $display the value of m is equal to percentage %d and n is equal to percentage %d comma m comma n, and ending this function. So within an initial beginning block, wherever I want to display the values of m and n, I can call this function display. So the values of m and n will be displayed here. So if I call it once, then the value of m and n will be displayed once, and if I call it twice, then the value of m and n will be displayed. So this function is not returning any value. This type of function is called void function. These functions are not possible in case of Verilog. So this is the concept of void functions in Verilog. Now let's see non-void functions. So in case of non-void function, we will not use the keyword void. If we want a void function, then we will use the keyword void. So I will write a module called tb, and in this tb I will declare two variables, int p comma, so I will assign p is equal to 10 and int q is equal to 20, and I will write a function called multiply, and for this my input is p and another input is q. So I should mention the direction here. My input is p and another input is q. So these are my two inputs for this function, and so I will declare here my output is multiply, and I can assign multiply is equal to multiply is equal to p cross q, and ending this function. So basically this function will multiply my inputs P and Q, and the output is stored in multiply. So in my output is stored in the variable multiply. So within an initial beginning block, initial begin, I will call this function multiply, and I will pass the inputs as 3 comma 4, and for storing that output I will declare another variable called int multiply underscore output. So here I will write multiply underscore output, and ending is initial beginning block and ending the module. So here what happens, I have declared a function int multiply, and my inputs are input P Q, and output is, I'm mentioning output as multiply, and I have written the logic inside, and I have entered the function. So here this is the function keyword and this is the data type. So remember this is the data type of output, or the value of the output which is getting from this function, which is nothing but in our case multiply. So the output data type is int. So the data type of mul variable is int. So our output is of data type int, and mul is the name of the function, name of the function. And my inputs of this function are p comma q, and output is mult. So whenever I'm calling this function mul and I'm passing this values 3 comma 4, so the value of 3 will be assigned to the variable p in the function which is declared as input, and the value of 4 will be assigned to the variable q which is also declared as input in my function arguments, and the function will compute a multiplication operation between p and q, and it will store the value which I have mentioned as mul. So it will store in the variable mul internally, and whenever I am passing another argument as mul underscore output, so here the value which is stored in mul will be transferred to or assigned to mul underscore output. So whenever I display, like if I write the statement $display, output is %d comma mul underscore output. So my output will be displayed, that is 3 into 4, 12 will be displayed. So this is how a function will pass. So this type of passing arguments is known as pass by value. So we are passing the values basically 3 and 4. So here we are passing the values to our function. 3 we are giving to p, and 4 we are giving to q, and we are getting the value mul to our mul underscore output. So we are basically passing the values. So this is called, this method of passing the values to our function argument is called pass by value. So this is how we can pass the values to our function and get the values from our function. So this is functions in SystemVerilog. So is this clear for everyone? Is there any doubt? Okay. So we also have return keyword in functions, and we can also use in tasks also in case of functions and tasks. So in SystemVerilog we can use the keyword return. Let's see how this keyword is using. So I will not write this everything. I will start with the function directly. So if we have a function called compute, and the return type is int, function int compute, input is P and Q, and my output is comp, and I'm computing comp is equal to A star B, and I will use return here, return comp is equal to A star B, and I will write comp is equal to A plus B, or I'll take another output comp underscore 2. I'll take one more output here, so this will be comp underscore 2 and ending the function. So within an initial begin and ending this block, I will call this function comp, and I will pass the values as 1, 2, and my output will be comp underscore output. Some register I will declare it. So here observe, my comp underscore output will be equal to 2. So here with the help of return keyword, we can directly come out of the function whenever we complete the operation. So when we use a return keyword, the simulator will come out of the function whenever it sees the return keyword. So it will not go further, like it will without completing the further operations, it will come out of the function. So without completing the further assignments also, the simulator can come out of the function with the help of return keyword. So with the help of return keyword, we can come out of the function or task without completing it. So without completing all the assignments which are in the function or task, we can come out of the function or task with the help of return keyword. So in SystemVerilog, we will use this return keyword to get out from the task and the function. So is this clear for everyone? So these are the introduction to functions and tasks in SystemVerilog. We will take one example of task also to getting understand. So I will directly I'll not write entire module everything. I will directly write a task syntax. Task int, return type is int, and I will use compute. Inputs are p comma q, and my output is compute underscore out, com underscore out, and I will use com underscore out is equal to #10 p cross q. So after 10 time units delay, p cross q value will be stored into com underscore out. Since it is a task, I can use a delay here and ending the task. And within an initial beginning block, I can call the task com, and I can pass the values like 3, 2, and I can get the value like output underscore com. I can declare some register and I can use it here and enable this. So like this, I can use a task inside my module. So this is the introduction to functions and tasks in SystemVerilog. So from in next session, we will discuss about static tasks, automatic tasks, and how to pass. We have already discussed the how to pass the arguments to these functions and tasks. So we have discussed the method of pass by value in functions and tasks. So we have another method which is called pass by name and pass by reference. We'll discuss in next sessions. So yeah, this is the introduction to functions and tasks in SystemVerilog.